in this screencast, we are going to talk about the E1 mechanism. Now, throughout the E1 mechanism, you are going to be able to draw a lot of comparisons to the SN1 mechanism. As a matter of fact, they start the same way. So if we look here at this friendly alkyl halide, all right, the very first step that we see is a heterolysis step, where this iodine pops off there. So those electrons that make up that bond go onto the iodine. When they do this, they form a carbocation. Now, when we make this carbocation, right, it looks like this, and you have to remember that there are hydrogens here on that beta carbon. And so what happens then is you have a nucleophile that's weak, like water, that comes in and it steals one of those protons, and then those electrons go there to make up a double bond. Now, a few things here. The leaving group here comes off before the beta proton here is removed. So this reaction occurs in 2 steps. This is a 2-step mechanism, right? And this is also first order kinetics. So it follows the rate law equals K times the concentration of the alkyl halide, which specifically in this case, the rate equals K times the concentration of CH3,3CI. Okay. Now, the first step is the slow step. So let's look at that energy diagram for the E1 reaction. And we can see here, here's our products, here are our reactants. We can see that this is the slow step because the activation energy is greater than the second step. We can see pretty clearly there are 2 steps. We can see the transition states here, and then the carbocation intermediate is shown here. Now, similar to an SN1 reaction, different things can affect the rate of the E1 reaction. And one of those things is the alkyl halide structure. And what we find with the alkyl halide structure is that the rate of the E1 reaction increases, right, as we go from primary to secondary to tertiary groups on the carbon, because we form more stable carbocations, right? So this tertiary carbocation is more stable than the secondary, and it's more stable to the primary. Now, this completely mimics what you see in the SN1 and reactions, because SN1 and E1 reactions have exactly the same first step. They differ in what happens to the carbocation. So in an SN1 reaction, a nucleophile attacks the carbocation, forming that substitution product. And in an E1 reaction, a base removes the proton, forming that new pi bond. So it doesn't surprise us, because the first step is the same, that we would see this be the same in E1 and SN1 reactions. Now, another kind of reaction condition that affects the reactions are bases. When we talk about a base in an E1 reaction, the strength of the base is usually going to be what determines whether the reaction follows the E1 or E2 mechanism. So a strong base like OH minus or OR minus, those favor E2 reactions. A weak base like H2O or an alcohol favors E1 reactions. So this is a really good way for us to differentiate between E2 and E1 reactions, is what base is being used. Now, Zatsev's rule also applies to E1 reactions. So what you'll notice here is that E1 reactions are also regioselective, right? Favoring the formation of the more substituted, more stable alkene, just like what we saw before. So this is a tri-substituted alkene. It's going to be the major product. It's produced in the greater amount. And then the di-substituted is the minor product. So I love a good summary. Here's an E1 mechanism summary. The kinetics are first order. The mechanism is 2 steps. The more substituted halides react faster. The rate follows tertiary, secondary, primary. It's favored by weaker bases like water and alcohols. A better leaving group makes the reaction faster, right? Because the bond to the leaving group is partially broken in the rate determining step. And polar protic solvents that solvate the ionic intermediate are needed. A lot of these are the same as what we see in the SN1 reaction. And the reasoning's the same because that first step is the same. Now, this is a really great comparison of the E2 to the E1 mechanism. And so when we talk about an E2 to an E1 mechanism, the E2 mechanism is favored by strong negatively charged bases, and the reaction occurs with primary, secondary, and tertiary alkyl halides, with the order of reactivity shown here. An E1 reaction generally is much less useful because a lot of times you get a mixture of SN1 products in there because that first step is the same, right? And it's favored by weaker neutral bases like water and alcohol. And this mechanism does not occur with a primary alkyl halide because they form those really unstable primary carbocations. So this concludes our screencast on E1 mechanisms. If you have any questions, please feel free to reach out.